third preparation method from the alkene is allylic substitution. What is allylic substitution? Alkenes, when reacted with the chlorine or bromine at very high temperature of about 500 degrees centigrade, the hydrogen of allylic carbon is substituted by halogen atom without affecting the double bond, and that we will call as allylic substitution. Clear? I have taken here alkene containing allylic carbon with hydrogen, allylic hydrogen. Clear? You know that this CH2, CH and CH2 is there, and it is called as a allylic carbon. You know the carbon next to the double bond we will call as allylic carbon. Now it is treated with the halogen. Halogen means you can take chlorine or bromine. Take the X2 here. I will write first example X2. X is equal to what? It can be chlorine or it can be bromine. And you have to maintain very high temperatures or about 500 degrees centigrade or 773 Kelvin. Now, and hydrogen of allylic carbon is substituted by halogen atom. Means you will get the compound is CH2 double bond CH and CH2Cl plus what you will get here HCl. This we will call as allylic substitution, and you can write here X. X means what here? X can be chlorine or bromine. Means you should not use iodine here actually. Why? Because previous we have discussed, and if I write iodine here, Hi you will get. Hi is a powerful reducing agent and it reduces this compound into this. So backward reaction, it reversible reaction that is. So that's why you should not use here iodine. Clear? Now this is the allylic substitution. I will take simple example here. Suppose if I take another one, this is. Now I will take here bromine and same I will maintain 500 degrees centigrade. Sometimes they will give delta here, means it indicates the temperature, high temperature. Sometimes in the presence of UV light also they will give. Clear? So that is allylic substitution. You know this carbon, double bonded next carbon, here this carbon and this carbon. Both carbons are which one? Allylic carbons. So that's why one of the carbon is hydrogen will be replaced by halogen atom. Then you will get the HBr. This we will call as allylic substitution. And what are the reagents used in the allylic substitution? Reagents. What are the reagents used in the allylic substitution? One is halogen. I already mentioned here at 500 degrees centigrade. Yeah. Or sometimes that is delta they will give, or sometimes they will give UV light also. Okay. This is one reagent. And another one is NBS or NCS. This is called as suppose NBS is there, NBS. This is N-bromosuccinimide. N-bromosuccinimide. What is the formula of this compound? This is succinic acid, you already know, CH3COOH you will get, COOH and COH. Amide means N, bromine means here, so the N bromine will be added. If chlorine will be added, that is NCS. Clear? And another one reagent is there here, sulfuryl chloride, that is SO2Cl2. You have to maintain 200 degrees centigrade in the presence of UV light. If they give alkene with these reagents, then that is a allylic substitution. Clear? And this is about the allylic substitution. Pause. Next one, based on these three concepts, I have given some examples here. And now this is alkene. Now you have to add the HBr. You know, addition of HBr to the alkene follows which rule here? Markovnikov rule. Follows which rule? Markovnikov rule. So according to the Markovnikov rule, you know that the negatively charged ion attached to the double bonded carbon where the number of hydrogens are less. and here number of hydrogens are less and here number of hydrogens are more. So that's why what the compound you will get is here, and you will get HH and CH3 and Br. This is the compound. Next one, if you take HBr peroxide, peroxide means you already know anti-Markovnikov rule. It follows which rule here? Anti-Markovnikov rule. Reverse product you will get. Means you will get the compound, and here bromine and here CH3. H will be present here. And another one is HCl in the presence of peroxide. You know that in the first year we have already discussed the anti-Markovnikov rule. It is applies only the addition of HBr. HCl and HI cannot be, it is anti-Markovnikov rule, it cannot be applicable for HCl and HI. It is only applicable for HBr. So that's why if they have given, in this case they have given HCl and peroxide, and we will think here peroxide is there, so that's why it should follow the anti-Markovnikov rule. But it will not follow the anti-Markovnikov rule. To confuse you, they will give like that. Clear? Anti-Markovnikov rule is only applicable for HBr, not for the HCl and HI. So that's why you have to write here Markovnikov product only. So that's why what the compound you will get here, and H, here H and CH3Cl. Next one, bromine CCl4. Bromine CCl4 is used to detect the presence of double bond in the compound. So that's why where the double bond is there, bromine atoms will be added. And here bromine and hydrogen is there, and CH3, and here bromine atom. Next one, bromine at high temperature means what? Allylic substitution. You know, this is allylic carbon and this is also allylic carbon. Clear? And you know, in this case, and here 3 allylic carbon atoms are there. So here allylic position, which one is more? It is, you know, allylic substitution follows the free radical mechanism. Where the free radical getting more stable means which free radical? If you remove the hydrogen here, you will get the primary free radical, but here secondary free radicals. So these two are more stable than this. So product will be formed either this carbon or this. So that's why you will get here bromine and a double bond and CH3. Clear? Next, NBS, same. This is also. You will get the compound is Br. And this is, you know, all these 3 are reagents for allylic substitution. Okay? So this is about the, means clearly you can understand, and HBr, which rule you have to follow, HBr with peroxide, which rule you have to follow, bromine and CCl4 means addition of bromine at double bond, and these 3 reagents are there, and these are the allylic substitutions. Clear? So next preparation method is from alkanes. Alkyl halides can also be prepared from the alkanes by treating the halogens mainly with the chlorine and bromine in presence of light. And this method, why I have mentioned, mainly by using this method we will prepare alkyl chlorides and alkyl bromides. Alkyl iodides also can be prepared, but you have to use some oxidizing agents. Why? And that we will discuss. And alkyl fluorides cannot be prepared by using alkanes. Alkane fluorides cannot be prepared. See, let's see example here. And I will take one example and CH4, and I will write here X2. X is equal to what here? Chlorine and bromine. And UV light, H nu means light. You can write here in presence of light. This reaction you have studied already in the first year. I will not go through detail. And here you will get the compound is CH3Cl. Mixture of compounds you will get. And this reaction will not stop here. Further, the chlorine will react this compound and you will get the CH2Cl2. You have studied already in the first year. Chloroform and CCl4. Clear? And this method is not convenient method to prepare the alkyl halides from the alkane. This method is not convenient. Why? Because means, and it is very difficult to separate the individual compounds from the reaction mixture. Because I wanted to prepare CH3Cl, but I am getting what it is. I am getting the mixture of compounds. If I wanted to separate this, it is very difficult from this reaction mixture. Clear? If I take suppose another one example, CH3 and CH2, CH2, CH3. If I write X, I have written here. Suppose if I take X means this is X, X2, this is X3, and this is X4. We have to write the X4 here. Clear? If I write here Cl2, this simply we will call halogenation. Clear? And chlorine, in the presence of light, UV light, you can write HNO also, UV light. Then what the compound you will get? I will get the compound here CH3, CH2 and CH2Cl. If I take excess amount of this, then the monochlorination stops. The reaction stops at monochlorination. And I will discuss that is also. Then CH3, CH2 and Cl and CH3. Two compounds are formed. If I want to prepare here primary alkyl chloride, but I am also getting secondary alkyl halide. So separation is very difficult. So that's why this method is not convenient method to prepare the alkyl halides. Clear? Suppose why we to prepare the alkyl iodides, why we have to use some oxidizing agents. Suppose I will write here CH3 and CH3. If I treat this one with the iodine in presence of light, then what happen is, suppose just assume monoiodo compound has formed, then what the compound you will get here? Hi. To get the mono compound here, mono halo compounds, you have to take the excess amount is alkane. Clear? Now, what is the product here? Along with this, you are getting Hi also. Hi is a powerful reducing agent. So that's why it reduces this compound into CH3 means ethane plus iodine. Means in the presence of Hi, this reaction is reversible. In the presence of Hi, this reaction is reversible. So that's why, and this method is not convenient to prepare the alkyl iodides also. So if you want to prepare alkyl iodides by this method, what you have to do? You have to use here oxidizing agents. You have to use oxidizing agents like you can use HNO3 or HiO3 or HZO, etc. If I use these oxidizing agents in this reaction and these oxidizing agents reacted with the Hi, means suppose I will take Hi, and if I use HiO3 in this reaction, it will react with HiO3. Clear? Then what the compound you will get? You will get the H2O plus iodine. H2O 3 and means 3 oxygen atoms are there, 3, then total 6 hydrogens are there, already 1 hydrogen here, 5. See now, and here if I use oxidizing agent, this oxidizing agent reacted with the Hi and it oxidizes the Hi into I2. Means we are removing this product. Byproduct we are removing by adding the oxidizing agent. If we are removing the product according to the Le-Chatelier principle, the reaction move in the forward direction. So that's right. Clear? And next one is alkyl fluorides cannot be prepared by this method. Why? Because you know that fluorine is very reactive, so that's why the reaction leads to explosive. Yeah? And what is the order of reactivity of alkyl alkanes here? And here tertiary alkanes more reactive than the secondary than the primary. If you take the reactivity order of the halogens, fluorine is more reactive than the chlorine, than the bromine, than iodine. Clear? So that's why, and you know we will get the mixture of the products in this reaction. So this method is not convenient method to prepare the alkyl halides. So now if you want to prepare, suppose first reaction I have taken and Cl2 in the presence of light. If I wanted to prepare only methyl chloride, then what I have to do? To prepare only methyl chloride here, you have to take the excess amount of the methane. If you take more amount of the methane, then chlorine will react to less amount chlorine, so that's why you will get the CH3Cl only. If you want to prepare CCl4, then what you have to do? Take the CH4 and Cl2, take the excess amount is this. Then what you will get here? Finally means the reaction will not stop here. It will go to the CH2X2 and CHX3 and last you will get the CCl4. Clear? So this is about the preparation of alkyl halides from the